Welcome learners. I am Dr. T. Gangaram, lecturer in statistics, SVA Government College, Srikalahasti. In this video lecture, we will discuss marginal and conditional distributions in continuation of simulation of continuous random variables and giant probability distributions. Here, why do we need marginal distributions? Think about it. Suppose the giant PDF is f of x, which describes the behavior of x and y. But what if we are interested only in the random variable x? The giant distribution contains both x and y. Suppose x is equal to tablet weight and y is equal to dissolution time. If the quality control engineer wants to study only one tablet weight, only the tablet weight, the resolution time becomes unnecessary. How can we remove the effect of y? Here the giant PDF is a combination of both variables x and y. How can we obtain information about only one random variable from a giant distribution? This gives us a solution of marginal distributions. Here the definition of marginal distribution is a marginal distribution is obtained by eliminating one random variable from the giant probability density function. If we eliminate y, then we can obtain f of x is called marginal density of y. Similarly, if we eliminate the effect of x, then we obtain f of y. It is called the marginal density of y. Here, the giant probability density function can be calculated but can be used to find marginal of y and marginal of x. Here, the key idea is giant distribution, marginal distribution, single random variable. How do we obtain the marginal density of x? Suppose we are interested only in x, then we must remove the effect of y. How? By adding, that means integrating all densities along the vertical direction. We are taking x in horizontal direction and y in vertical direction. By adding the values of y, by integrating over y, we can remove the effect of y and find the value marginal of x. Similarly, f of x is equal to integral f of xy dy. Therefore, f of x is equal to marginal of x is equal to integral f of x dy. Here we need to integrate vertically. This is the region, support region. By integrating vertically, and that means over the range of y, we can get the marginal of x. Here memory trick is to obtain f of x, integrate with respect to y. Given giant random density function, f of xy is equal to xy by 1250. The range of x is 0 to 10 and range of y is 0 to 10. We wish to find the marginal density of x. Since f of x is equal to integral f of xy dy, substitute the given giant density f of x is equal to 0 to 10 xy 1250 dy. Here, notice that the limits are over the range of y. 0 less than or equal to y less than or equal to 10. Because we integrate over the entire support, this is the range of the marginal of x. Observation is to obtain the marginal density of x, we integrate over the entire height of the support region. From the previous frame, we obtained f of x is equal to 0 to 10 xy 1250 dy. The next question is, can we take x outside the integral? Notice that 0 to 10 xy 1250 dy is equal to 0 to 10 x by 1250 into y dy. Since the integration is performed with respect to y, x does not change. Hence, x divided by 1250 acts like a constant. Therefore, we can get the x value outside. F of x is equal to x by 1250 0 to 10 y dy. Here, the range of x and y are same, but we need to take the range of y to get the marginal of x. Here x is fixed, y changes. The golden rule is during integration with respect to y, x is treated as a constant. Only variable of integration changes. That means y changes. Here, in the previous frame, we obtained f of x is equal to x by 12500 to 10y dy. How to evaluate integral y dy? Recall the relationship between differentiation and integration. D by dy of y square by 2 is equal to 2 into y divided by 2. 2 gets cancelled. D by dy of y square by 2 is equal to y. The function y square by 2 is called the antiderivative of y. Therefore, integral y dy is equal to y square by 2. Here, by doing integration, y will become y square by 2. By doing differentiation, y square by 2 become y. This is the relationship between integration and differentiation. Integration is reverse of differentiation. Remember, if d by df of capital F of x is equal to small f of x, then integral f of x is equal to capital F of x plus c. Here, using the result of integration, f of x is equal to x by 1250 0 to 10 by dy. Here, we know that integral y dy is equal to y square by 2. Replace the integral by its antiderivative 1250 in place of integral y dy. We can substitute y square by 2 over the range 0 to 10. Here, we this means upper limit minus lower limit. The next step is substitute y is equal to 10 and y is equal to 0 in this form. So, by substituting this f of y ab is equal to f of b minus f of a. This is the fundamental, according to the fundamental theorem on calculus. By substituting this, we can get, now simplify the term, and 50 is the answer for the y square by 2 0 to 10. Now substitute the value of the integral from the previous frame. Y square by 2 0 to 10 is equal to 50. F of x is equal to x by 1250 into 50. By 50 and 1250 gets cancelled. This x by 25 remains. Now our marginal density of x is equal to x by 25 over the range 0 to 10. Outside the interval, it is equal to 0. Property of, let us verify the marginal density of x. The property of probability density function. Every probability density function must satisfy integral f of x dx is equal to 1. Let us verify whether our marginal density satisfies the property or not. Now, f of x is equal to x by 25 over the range 0 to 10. Substitute this and integrate this 0 to 10 x by 25 dx. Does the integral evaluate to 1? Let us verify step by step. Now, this since 0 to 10 x by 25 dx is equal to x square by 2. 1 by 25 is the constant. We can take this outside, so it becomes x dx. Now, integral x dx is equal to x square by 2. 1 by 25 into x square by 2, 0 to 10. From this is 100 by 2 minus 0 square by 2. 100 by 2 is 50. Now, this integration is equal to 2, not at all equal to 1. So, this is not correct. Now, we obtain f of x is equal to 20 x by 25. Let us verify whether it is a valid probability density function or not. It is equal to 2. Is this correct? Think, every probability density function must satisfy f of x integral f of x is equal to 1, but we obtained 2. What does it tells us? It tells us this integration must be equal to 1. The valid giant probability density function must be equal to 1. Substituting the given function, already we know that this is the value evaluation to 2. Therefore, f of xy is equal to 1250. This is not a valid giant probability density function. It is mathematically correct, but the given function is incorrect, since this probability density function does not satisfy the primary condition of total probability must be equal to 1. Given f of xy by 1250 over the range 0 to 10, 0 to 10, we wish to find the marginal of y. Next, our task is to find marginal of y. For this, we need to find marginal of y is equal to integral f of x y dx. So, substitute the given joint PDF instead of f of xy by 1250 integral dx. We need to integrate over the entire support of it is horizontally. Integrate along x. So, to obtain the marginal density of y, integrate over the entire width of the support region. Whereas for x, we take height as support region. From the previous frame, f of y is equal to 0 to x, xy dy dx. So, simply we can take y by 1250 as constant, and we took it outside, and integral 0 to x dx is x square by 2. Therefore, f of y by 1250 x square by 2 is equal to, this is nothing but y by 25. And therefore, f of y is equal to marginal of y is equal to y by 25 over the range 0 to 10. Outside this interval, it is 0. Observation is the marginal density of y has exactly the same form as the marginal density of x. Here the marginal of x is x by 25, marginal of y is y by 25, support is 0 to 10 and 0 to 10. Are these valid probability density functions? We need to verify before proceeding. Here, marginal distributions at a glance, the marginal of x is interested only in x. Eliminate y. The calculation of marginal is f of x is equal to integral f of xy dy vertical strip integrate with respect to y. Similarly, marginal of y is interested only in y. Eliminate x. F of y is equal to integral f of xy dx horizontal strip integrate with respect to x. The memory trick is to obtain one marginal integrate with respect to the another variable. I wish you all the best. I thank ChatGPT and Gemini.